Hello everyone, welcome back to Who's Computer Science Projects. So today we are starting the tutorial about making a project like the one we saw in the first video. And if you haven't seen it yet, please have a check out to see what is going on. So you will be very comfortable about following along in this tutorial. So this first video will be about how to track the landmarks into our hands and how to broadcast that data so that Unity can receive them and process them. So enough talking now, let's jump to the computer and let's get started. So here we are. I have decided to use a PyCharm project instead of a Jupyter notebook because it will be very simple to just have a Python file. So when you start a PyCharm project, you should have something like this, a virtual environment. And if you have trouble about making a virtual environment, let me know down in the comment below and I will make a video specifically about how to build virtual environments, and not necessarily using PyCharm, but just by using bash commands. So I have just one file here and it only takes like 42 lines, and believe me or not, yes, that is very enough to build what we want. So before we jump to the code, let's install some stuff. And because we are in the virtual environment, we are completely independent from outside the virtual environment. So I've already installed, but I'm just gonna show you so you can follow along. So first thing, pip install media pipe like this. I've already installed, so that's okay. So the next step is CVZone. So CVZone is a package that is built from MediaPipe and OpenCV-Python. And about MediaPipe, let me dive into the documentation. So this is MediaPipe hands, and it is able to track key points on the hand, just like you see in this animation. And so if we go down, yeah, so each key point has an ID. So the wrist has an ID 0, the tip of the thumb has an ID of 4. And these are the same every time, so we can keep track on which part of the hand it is. So let's go back to the code. So now let's dive into it. So we'll have from cvzone.hand tracking module import hand detector, import CV2, and import sockets. We'll see about that later. So first thing we do is cap CV2 video capture 0. So the 0 is using the first webcam. If you have a built-in webcam that just like I have in my Mac, then you can use that. But personally, I will be using an external webcam just because the quality will be way better. So I will be running into one instead. But just for this demo, I'm just gonna use my normal webcam. So I need to put 0. Next, this is just to set up the dimension. You can actually skip those two lines if you wish, but it will give you obviously less control. Then we have the success and image equals to cap.read. So we'll have the success, whether we got an image or not. And then we have the image itself. If we don't have any success, then the video is not detected. Next, so that is again an optional thing. And next we have this. So what we do is just flip the image just like if it was a mirror. So next we will have the height and the width that is equal to the image shape. And then we have the while true, success equals to image or cap read. So that is basically updating what we have in the webcam. If you don't do that, we will just take the image from there, and then we'll have a static image about the first frame called by the webcam. But we don't want that. We just want to read the webcam normally, so we have to update every time. And then, just like in the first tutorial about the Sudoku, cv2.imshow image. So that is the name of the GUI, and that is the name of the image. Actually, the NumPy array, the image itself. Then we have cv2.waitKey1. So let's execute this. And here we go. So it is capturing from my webcam. But we can't see any key points on my hand yet. So let's do that now. It is very simple. So first you'll have detector equals to hand detector that we have imported here. Then we have the detection confidence, which is equal to 0.8, and the maximum of hands. Sometimes you can set at 2, at 3, but I will choose 1 because there will be one hand in Unity anyway. And then the last thing is hands and img equals to detector find hand img. So basically the image that you can see right there will be changed by passing it to this function. So you will be able to see the landmarks, and this is about the result. We will not go through that yet. Let's just rerun the demo and to see where the landmarks will be written or not. Okay, and now here we go. I can see landmarks on my hands, and I can also detect whether it's a right hand or not. And let's do it on my left. So that's pretty cool. And next, okay, so we'll have a list, an empty list, which is called data. You will see later what is this for. Okay, so in order to get the landmark position, the coordinates, we will have to do the following. So hands equals to hands 0, and then you have to call landmark list equals to hands landmark lm list, which stands as landmark list. And then for id lm as a landmark in enumerate lm list. So what we are doing is looping through all of the landmark list, but we are also capturing the ID, and the ID is exactly the same as I have shown earlier. And by the way, a very important notice, there are 20 landmarks in total. So the next we'll have data extends the landmark 0. Let me actually debug this just to show you what it looks like. So ID, and then we'll have the landmark itself. Okay, so I just have to show my hands. Then it has pointers and stuff. Okay, so we will have the 0, which is the ID, which is the wrist of my hands, like you see in the picture in the MediaPipe documentation. And then you can see some coordinates, so 318 and 585. So that is the X coordinates, Y coordinates, and the Z coordinates. But there is a problem with the Y coordinate, because there is a slight confusion, because in OpenCV we read the Y value from the top as the bottom. So what we are doing here is not just the landmark 1, which is equal to the Y, it is the height minus the landmark 1. And then we have the landmark 2, which is equal to Z, and the landmark 0, which is equal to the X. So why are we doing data extend? So this is basically to have just, instead of a list of 3 elements, we will have just one list with all the 3 elements packed together in the same list. And I can show you that again by debugging. So we'll print data. So I just have to show you my hand. Yeah, okay. So as you can see, you have a big list with all the coordinates packed together. So this is the point 0x, point 0y, and point 0z. Then you directly jump to the landmark 1x, landmark y, and landmark 1z. Then you have the same for landmark 2, then landmark 3, and so on until we arrive at the end. So if we do 21 landmarks, and we have 3 values in each of them, x, y, and z, that means that we have 63 values in each list. So that is completely normal. So we are done with the data, but now we need to find a way to broadcast this data. And to do that, we will use a socket to send data over an IP address. And for that, we will just use the local host. So we initiate the sockets like this. Then we initiate the server address port. So just pass the IP address. So that is the IP address for localhost, and it is the same for all devices. Then we have a port number. So about the port number, you can choose any of them. Just make sure that it is not used by something else. Well, anyway, it will tell you if something else is using this port number. And you also have to make sure that in Unity, you are receiving data from the same port number. And the last step is this. So obviously this long list, the data one, we will convert it into a string. Well, we must do that if we want to send through the sockets. And then we can't just send the string data, we need to string encode, so we have a sort of a byte-like object, and we just tell which address and which port that we define over there. So nothing too fancy really. Well, it won't change anything. I just removed the debug, but if we run Unity and try to listen to this address and this port, we will receive data from it, then we can process the data from it. So that was it for this first tutorial. I hope you really enjoyed it, and I also hope that you are willing to wait for the second tutorial about this, where we'll get started with Unity. So the next video is obviously about Unity and how we can receive data from Unity. And by the way, Unity is coded in C#, not in Python, which may be challenging because it is not as easy as Python. But if you have done something similar to Java or C++, well, C# is not too difficult then, and I hope you will be comfortable when following along. So thank you very much. If you're still watching this, please don't forget to subscribe if you want to see more tutorials like this. Please also share this video and see you next time.